Okay, kids, we're going with this last bit of rules right here, guys. This really is kind of an interesting topic right here. There's this idea about Descartes' rule of signs. What this tells us is how many possible real solutions there might be and how many possible imaginary solutions there might be. And what this kid says is this. It says, let f of x be a polynomial function with what kind of coefficients? Real coefficients. It says the number of, okay, I'm going to highlight this, and you might want to underline it in your notes. It says the number of positive real zeros, okay, keep in mind, number of positive real zeros of f is equal to the number of changes in the sign of the coefficients of f of x, or is less than that by an even number. So less than that by going down by an even number would be going down by how much each time? 2's. Okay, so let's talk about this. The number of positive reals can be the following, kids. In this function right down here, first of all, what degree is my function here? Okay, if I had to find the zeros of this right here, how many total zeros should there be for that function? 6. Okay. This first rule up here says the number of positive real zeros of f is equal to the number of changes in the sign of the coefficients. Here's what this means. Take a look at this right here. What's the coefficient on my 6th degree function? So it's a positive 2, right? I go from a positive 2 to the next coefficient, which is a negative. So was there a sign change? I went from positive to the next coefficient being negative. Was there a sign change in the coefficients? Thank that. That's 1. Okay? Now, go to the next one. From negative 5 to negative 3. Is that a sign change? No. So are we counting that one? No. Then the next one, I'm going from negative 3 to positive 3. Is that a sign change? Yes. Then I'm going from positive 3 to positive 10. Is that a sign change? Going from positive 10 to positive 1. Is that a sign change? Going from positive 1 to negative 9. Is that a sign change? Okay. Question becomes this. The way the function is right now, at most, how many positive real solutions? 3. So I'm going to write this down here. Here's what I'm going to do. This table, I know how this table is set up, and I want to show it to you right here. So the number of possible, put a 3 here and a 3 here. Okay? It's possible that there's 3 positive real roots here, according to his rule. Okay? Now, it said it can be less than by an even number. So what's 3 less 2? Or 3 minus 2? It would be 1. So guys, this either has 3 positive real zeros or 1 positive real zero. Okay, so write those down. And I'm going to use that to finish the chart. Now, I'm going to go below this chart here a little bit because I want to talk about the second part. The second part says the number of what type of real zeros, kids? So a 0 might be negative 7 or negative 22 or something like that. It says the number of negative real zeros of f is equal to the number of changes in the sign of the coefficients, not of f of x, but what? Negative. Okay, let me write this down right here, kids. I have a question for you. True or false? Positive x squared is equal to negative x squared. True, because a negative times a negative would be a... Okay, how about this? True or false there? Why is that false? This would turn out to be a negative. A negative times a negative times a negative would be what? Negative. And this here is positive. So guys, for this other part right here, for this negative, how do you test the negative reals? Right here, I'm going to make a note on testing negative reals. Anytime you're trying to figure out how many negative reals there are, you're going to do the same exact thing. You're going to look for sign changes up here. But the situation is this. We're not putting x in anymore. We're putting negative x in. And you just told me that x squared is the same as negative x, all to the second power, right? Anytime your powers are even up here, they will always stay the same. If you have anything with an odd power, however, what was true about these odd powers right here? Were these the same or different signs? Okay, when you want to test negative reals, what you end up doing is change You really are changing your sign of all odd powers. So guys, to check for negative real solutions, here's what we would do. Would 2x to the 6th, would that sign change or stay the same? It's going to stay the same because the exponent is even here. Okay, but what about this coefficient sign? Am I going to keep it or change it? Because the exponent is odd. So here's what I want you to write down. I want you to write down to check for negative reals. We're going to go ahead and call this now 2x to the 6th. Anything that has an even exponent, that coefficient sign will stay the same. Anything with an odd exponent, you want to change the coefficient sign. Okay? So is this going to be what next? After 2x to the 6th, what would I have? Plus 5x to the 5th. Okay, do I need to change the 3x to the 4th? Nope. Do I need to change the 3x to the 3rd, though? Okay. Minus 3x to the 3rd. Let's see, I got x squared, that stays the same. Okay, this is like x to the 1st, isn't it, kids? So this will be a minus an x then. What about the 9? That's like 9x to the 0. Is 0 even or odd? 0 is actually even, so you wouldn't change that sign. Okay, let's check and see how many sign changes we have for negative real zeros here then. Okay, going from a positive to a positive. Does that count as 1? How about now? That's 1, isn't it? Is this a sign change? Is this a sign change? Is that a sign change? Went from a negative coefficient to a positive coefficient, so that's my second one. Going from a positive down to a what again, kids? Negative, so there's another one. And then when negative to negative, no. So how many possible negative real values are there? 3. Okay, here's what I want you to write down. Put your 3 here and your 3 here. Okay, so for negative real zeros, same thing. You change the signs of the odd exponents, and then you just check your sign changes. Now here's the deal, kids. Let's just talk about this right here. If you have negative real zeros, possibly 3, that could be the number of coefficients or less than this by an even number. So it's possible that there could be 3 negative zeros, or what else? Or what else? Okay, put this a 1 here and a 1 here. And I'll show you why we're making this table the way we are. All right, kids, let's talk about this right here. If it's the case where we have 3 positive reals and 3 negative real zeros, how many imaginary zeros would you have? How many total zeros should there be for this function? 6 of them, right? So if you had 3 positive reals and 3 negative reals, how many imaginaries would there be then? Well, none, because we have to have a total of 6 zeros, okay? What if we have the case where there's 3 positive zeros and 1 negative zero? How many imaginaries would that force? How many? 2, because the total has to be what here, kids? What if we have 1 positive zero and 3 negative zeros? How many imaginaries would you have? Got a total 6, right? What if you have just 1 positive and 1 negative? How many imaginaries are there? 4. Because you have to total what? Okay. So you're always looking at sign changes. For the positive real zeros, it's the original polynomial function. Okay? And then for negative reals, you have to change which exponents? Odd or even? And then check your sign changes from one term to the next. And then you just end up filling out the chart. No matter what, the total zeros in any case should be what? No matter what, you should have a total of how many zeros? 6. Okay, let's just graph this quickly and see what it looks like, and we'll figure out which one's correct here. All right, Desmos. Do I have a volunteer that would be... Kylie, you're always good at reading me the problems. Would you be willing to do that for me?
Mm-hmm.
The function that we just talked about. The 2x to the 6 is how it starts, right?
Yeah.
What's...
Minus 5x to the fifth, minus 3x to the fourth, plus 3x to the third, plus 10x to the second.
3x to the third, right? Minus 10x squared?
Plus 10x squared. Plus x. Minus 9.
Okay, let's just take a look at this, kids. Let's just see what happened here. Here's my graph. Guys, here are my zeros. I'm going to squeeze this together a little bit. So hit hold and shift and... Guys, how many zeros does it appear it really has that are real? Okay, it looks like it has one positive 0, one negative 0. So that means the other 4 have to be what, kids? Imaginary. So the column that's actually right here, I've got one negative 0, negative 0.97, another one at 2.597, which means the other 4 must be what type of zeros?
It's the final column.
Is it? 1, 1, 4, and 6. You're right. It is that one right there. So this is the one that's actually correct right here. There's one positive real 0. There's one negative real 0, and then there are 4 imaginary zeros to total 6. Okay. You guys get this idea of sign changes? What I'm talking about here? Okay with that? Okay. Well, let's finish up this last problem here. And then I'll get you a short, quick quiz and some time to work on some things. How many got a chance to start the online already? How many problems were there? Like 7 or so? Did you guys, were you able to get a decent start on it? Okay with it? Okay. Well, let's check this last example then. Any questions so far? Okay, let's apply this right here. It says a tachometer measures the speed in revolutions per minute at which an engine shaft rotates. For a certain boat, the speed x in hundreds of RPMs of the engine shaft and speeds s in miles per hour of the boat are modeled by. S is modeled by this polynomial function here. I won't read it. It says, what is the tachometer reading when the boat travels what? 25 miles per hour. Okay? We've got to figure that out. So they're basically saying the boat is traveling how fast, kids? Boat is traveling how fast? Okay, so here's what we're going to do, kids. I'm going to come up into here. I'm going to let the speed be 25 miles per hour. Whoops. I'm going to let speed right here. I'm going to replace that. I'm going to replace this right here with 25 miles per hour. So here we go. We end up with the following. 25 equals 0.00547x to the third minus 0.225x squared plus 3.62x minus 11. Now, kids, everything in this section has been focused on finding the zeros. Okay? Is my polynomial function equal to 0 at this point?
No.
Could I make my polynomial function equal to 0?
Yes.
I could. Okay? What would you have to do to make this equal to 0? Subtract 25, right? So if I subtract 25 over here, that would combine with the minus 11. So here's what I'm telling you to do, kids. I can go 0 equals 0.0. Let me just ask you some questions here. Could I use rational theorem on this? In other words, could I make a P and a Q list for all this stuff? Are all my coefficients whole numbers?
Yeah.
No, they're not. So I can't even figure out what P and Q are to try and figure that out. Okay. Should we see what Math Papa can do with this?
Oh yeah.
Let's try it. Let's see what he says, all right?
That big pop.
When you get in trouble with this, who are you going to call?
Big
Math
pop.
Papa.
All right, let's check it out and see. Now, Kylie, can I call on you again? Because you're really good at helping me out with this here. So I'm going to find him. But I think there's a better way to probably do this. I don't want that. Where are you, Parson? You're in LaPorte City. All right, never mind. Yeah. Parson, there you go. Which calculators? What was it? The factoring calculator way at the bottom, is that right? Let's try to type an equation in this thing and see what happens. Okay, Kylie, I'm ready.
1.00547x
To the,
to the third
okay,
minus 0.225x squared plus 3.62x minus 11.
okay, and actually we changed it to minus 36 there, didn't we?
Oh,
Okay, so I'm going to go minus 36. Is that okay? And I'm going to set this equal to, actually, I think if you come here and set this equal to 0, it might calculate this for you. Or it might say, ooh, I don't like this. Oh, it does give you an answer, kids. Check that out. What do you get here? 25 point, we'd probably call it 25.25. Okay. Now I want to show you another thing here quickly too. Think about decimals. What we had there. Kylie, I'll try and go from memory here, but I think you said 0.00547x to the third plus minus 0.225x squared plus 3.62x minus how much? Okay, I want to go back to my question here, kids, and see what this is really saying. But the question here is saying, what's the tachometer reading when the boat travels 25 miles per hour? So right here, x is measured in what, kids?
RPM.
Hundreds of RPM. So when we get an answer on this, we're going to have to times by what value in the end? Okay, Math Papa said what value here again? 25.24, which means we'd probably move the decimal 2 to the right, so about 2,524 RPM. Let's just see how that relates to decimals here quickly. I'm going to go up here to the x-axis here. Again, we're looking for a 0, so squeeze that down. Oh, hang on a second. There's my 0. What value do we get again? 25 point what? So the whole idea here is this: if you start seeing things with something that it does not have integer coefficients on it, you need to say, okay, the factoring that's going to be next to impossible. Okay, so you want to set your polynomial equation up so it's not equal to 25. You want it to equal what? 0. And once you have your 0, you have two options. You can go to that factoring calculator and put it in as an equation, or if you just want to type it in decimals and look for it graphically, either way. Now again, 25.24 is our answer, but keep in mind, this is 25.2400, so I'd have to move the decimal how far to the right? So what's the tachometer reading? What's the tachometer reading on this boat when you are traveling 25 miles per hour? I'm going to say by decimals or 2,524 RPM, right? Okay. I know there's some boys out in the north parking lot in the morning that have RPMs way higher than 2,500 in the morning.
Dylan.
Cole.
Am I wrong about that?
No.
Guys, what questions do you have here? There's a lot in a little bit of time here. I want to give you a little time to work on a quick quiz today. I'm going to get you the practice. It won't be due until Friday. I pushed this last book assignment. It said Thursday originally. I'm not going to collect it till Friday. All right? So, questions for me first.